right, the last thing we want to look at here in section 1.8, quadratic equations, are other types of equations that, in the process of solving them, become quadratic. So because you may have to, multiply both sides by a variable expression, or because you may have to square both sides of the equation, you have to, again, watch out for extraneous roots. Folks, anytime you have a variable in the denominator initially, or if you have a radical involved in the initial equation, you have to make sure you check your solutions to make sure they satisfy the original equations, okay? If they do not, then they're just generated because of the problem-solving process, but they would be called extraneous solutions or roots if they do not work in the original equation. All right, so let's get started here with number 1. So notice in this one, the denominators are the same. So if you multiply both sides by x minus 1, they are just going to cancel out. So I'm multiplying both sides of this equation by x minus 1, and that would eliminate the denominators, okay? That's how you always get rid of denominators. Multiply both sides by the LCD. In this case, the LCD is only this x minus 1. It's the only prime factor. Okay, so what do we get? We get x squared is equal to 3 minus 2x. All right, so at this point, I'm going to set it equal to 0 and see if I can factor it, see if I can solve it by factoring. So I like, again, to keep my quadratic term positive. I'm now going to add 2x to both sides, and then I'm going to subtract 3 from both sides. And yes, I'm pretty confident we can all factor this one. This is prime, so it has to be a 1 and a 3. Then you just got to worry about your signs. So it's a positive 2. So that means 3 has to be positive and 1 has to be negative, okay? So there's the correct factorization of this quadratic expression. And now let's solve this thing. So you end up with what? This factor would generate what 0? It would generate a 1. And this factor would generate what? A negative 3. So we just put a box around it, correct, type it into WebAssign, move on, right? No. What did I just tell you? If you have to multiply both sides by a variable expression, or in other words, if there's a variable in the denominator, you got to check to make sure each of your solutions actually does work in the original equation. Look at this 1. If you plug a 1 into this x, or this one, doesn't matter, they're the same. What are you going to get in the denominator? You're going to get a 0. You cannot divide by 0. So that's what you're really looking at if you ever see a variable or variable expression in the denominator. You have to make sure when you plug in your solution that it does not make the denominator equal 0. If it does, guess what? It is not an actual solution. It's an extraneous one. So your only solution here is negative 3. Negative 3 works. All right, finished with number 1. Moving on to number 2. This will be our final example in section 1.8. So what in the world are we going to do with this one? We have a radical involved. I know I can get rid of this radical if I square it, but I don't want to square it yet because I have a minus x attached to it. So let's go ahead and do this. Let's go ahead and rewrite the square root of 2x plus 8. And then let's add x to both sides. Let's add x to both sides, okay? And that would give me this. Now I'm squaring both sides of this equation. So be alert. Be wary of what's going on. You're squaring both sides of this equation. If you ever have to square both sides of an equation, you could be gaining a root. And that gained root is going to be extraneous. Just check your final solutions that you end up with. Make sure they work. Okay, what do we get here? We get 2x plus 8 is equal to x squared. All right? So I'm going to leave the x squared positive, and I'm going to now subtract 2x from both sides. I'm also going to subtract 8 from both sides. So now I have my equation in the form I want it to be in. I could factor it, or I could use the quadratic formula. This one I believe is factorable. Let's see if we can factor it. So let's see, we get an x and we get an x, we get a 4, we get a 2, and then this has to be what, a minus 4 and a plus 2 to make sure we have a negative 2 in the middle, right? So then what we're doing is we're really setting each of these factors equal to 0 and solving for x. So we would get what? X equals 4 or negative 2. All right, now check these into your original equation. Does 4 work? Let's check. Stay with me. 2 times 4 is what? 8. 8 plus 8 is 16. Square root of 16 is 4. Does 4 minus 4 give you 0? Yes. So 4 checks out. 4 checks out. All right, negative 2. What's 2 times negative 2? 2 times negative 2 is negative 4. What's negative 4 plus 8? Negative 4 plus 8 is 4. What's the square root of 4? Square root of 4 is 2, right? So, okay, what's 2 minus a negative 2? 2 minus a negative 2, that's 2 plus 2, that's 4. Does 4 equal 0? No, 4 does not equal 0. Therefore, this is extraneous. It's not really one of our solutions. So the only solution here is 4. All right? It has to make sense. It has to make the given equation true when you plug it back in. And that completes the notes for section 1.8. Hope you're staying healthy. Hope you're having fun. See you again real soon.